Hello students, in today's class we will see Mason's gain formula for a signal flow graph. Okay, first we will see what is a signal flow graph. It is another way of representing a system, okay, using nodes and branches, right. We will see what is a signal flow graph. In a block diagram, actually what we did was, see, we gave like this, right. This X is the input signal and Y was the output signal and A is the block, right. If this is to be represented in the form of a signal flow graph, right, these signals will turn into nodes, okay, these are called as nodes. And see, the flow is from X to Y through this A, right. So you understand? So this is the signal flow graph representation of a block diagram. The signals are represented as nodes and the block is nothing but the gain or the transmittance of the path, and this is called a branch. And this A is also called as branch gain or transmittance, right. With this we will see how to solve a signal flow graph and get a transfer function from that, okay. Right. For that we have what is called as Mason's gain formula. Right. This is used to find out the transfer function of a system when we are given the system in terms of signal flow graph. This Mason's gain formula is called so because of the inventor, right. It was founded by S.J. Mason and so it has been given this formula. It has been given this a name, right. What is that formula state? For example, if T of S is the transfer function, which is nothing but, we know transfer function is nothing but Laplace transform of output divided by Laplace transform of input. So we have been seeing we have been representing C of S as the Laplace transform of output and R of S is being given as Laplace transform of input. Okay. Now, what does this Mason's gain formula state? It states that summation I is equal to 1 to capital N Pi delta I the whole divided by delta is the formula, okay, where this I varies from 1 to N, right. So N denotes the number of forward paths, number of forward path. What does the forward path mean? See, when I say this forward path, see, for example, let us draw a signal flow graph, right. I'll just write the nodes, number the nodes, okay. Okay. Now, let us say this is R of S and this is C of S, okay. This is G1, G2, G3, G4 and this is G5, okay. So how many forward paths are there? Forward path is nothing but, see, this is the starting node, input node, right. So this input node is nothing but a node which has only outgoing branches, right. Input node is nothing but a node which has only outgoing branches. See, this node has only outgoing branches, right. So this is called as the input node. And what is the output node? Output node is a node which has only incoming branches, right. So input node is a node which has only outgoing branches and output node is a node which has only incoming branches. So what we must do is to find out the number of forward path, we have to see how many ways are there to move from the input node to the output node, okay. How many paths are there to move from the input node to the output node? See, if we track these arrows, we can see we can go via two routes. How? 1 to 2, then 2 to 3, then 3 to 4 and 4 to 5. This is one path, right. What is the other path? We can go from 1 to 2, then 2 to 4, right, 4 to 5. This is another path. Is there any other means of going from 1 to 5? No. So there are two paths to go. So these two are the forward paths. So in this particular problem, the number of forward paths will be 2. Is it right? So this n is nothing but the number of forward paths, right? Next, what is this pi? This pi is nothing but gain product of the forward path. Okay, gain product of the forward path. For example, see in this particular problem, we have seen that the n is equal to 2 in the example problem, right? So we will be having how many? P1 and P2. We have two gain products, forward path gains. This is called forward path gain. So how many forward paths are there? 2 paths. So we have 2 forward paths gain. What are they? You multiply the gain of that particular path. For example, 1 to 2, 2 to 3, 3 to 4, 4 to 5, right? So you multiply the gains G1 into G2 into G3 into G4, right? So G1, G2, G3, G4. So this is one forward path gain. And what is the other one? The other way is 1 to 2, 2 to 4 and 4 to 5. So what is that? G1 into G5 into G4. So G1, G5, G4. Right? So this is nothing but Pi. Okay? So n is the number of forward paths and Pi is the ith forward path gain. Right? Okay. Next, what is that? We have to see what is delta I and what is delta. Okay, now let us see what is delta. Right? After that, it will be easier to find out what is delta I. Okay, what is the delta? See, this delta is equal to 1 minus sum of individual loop gains. Right? Alternately it comes 1 minus sum of individual loop gains. We have put minus here, so plus sum of gain product of any two non-touching loops then minus sum of gain product of any three non-touching loops plus so on. Alternately it goes. Right? So what is delta? Delta is equal to 1 minus sum of individual loop gains plus sum of gain product of any two non-touching loops minus sum of gain product of any three non-touching loops plus and so on, it goes on, right? Now you will have a doubt as what is meant by this loop gain. Okay, see, I'll give you an example for this loop gain also. See, suppose you have a something like this. Okay, okay, see in this particular signal flow graph, see what you can see, this R of S is the input node, right, because only it has outgoing branches, and what is this? C of S is the output node, it has only incoming branches, right? Now how many forward paths are there? Just there is one forward path. Okay, so forward path means we have to start from this input node and go to the output node without traversing any path repeatedly. Okay, for example, 1 to 2, 2 to 3, there is also a path from 3 to 2 and then from 2 to 3. Okay, so that should not be traversed. See, once you start from 1, move to 2, then 2 to 3, again you cannot come back to 2 because you have already passed that second node, right? So 1 to 2, 2 to 3 and 3 to 4, that is the forward path, right? Now, what is a loop? Loop is actually a loop starts and ends with the same node, right? So this, see node 2. From node 2 you have a signal going to node 3, right? And then from 3 again a signal comes back to node 2. So this is a loop. What is a loop? Here we have 2 to 3 and 3 to 2 is a loop. Okay, loops are generally given by L. And what is the loop gain? You multiply the gains in that particular loop. So 2 to 3, 3 to 2, what is it? G to H. So this is the loop. Okay. See, if we have a negative sign over here, what generally happens in case of a negative feedback, then the sign also has to be considered. Minus G to H. Understood? So this is a loop gain. Okay. Sum of individual loop gains means how many number of, depending on the number of loops in that particular problem, you have to add all the loop gains. Then gain product of two non-touching loops means if two loops are not touching each other. For example, see, suppose we have another loop. This is called a loop because see this node, this loop starts with node 4 and it also ends in the same node, but it doesn't travel to any other node. So this is called as a self loop. Okay, this is also a loop but with one single node. So it is called as a self loop. See, so how many loops are there? This is, let us assume that that is loop 1. And what is loop 2? Loop 2 is nothing but 4 to 4. So which is nothing but G4, right? So there are two loops in this particular problem, L1 and L2. And are these two loops touching or not? They are not touching because they don't have any node in common. In other words, I'll just redraw this. See, for example, 1 to 2, 2 to 3, 3 to 4, right? I'll just give you like this. I'll just draw the loop alone, right? This is a loop, 1, 2, 3, 4. See, this loop is separate and this loop, they are not touching each other. Right? So L1 and L2 are also non-touching. So when you're asked to find out this, write the sum of gain product of any two non-touching loop, this particular problem has two non-touching loops. Okay? So gain product of two non-touching means L1 into L2. Gain product of any two non-touching means L1 into L2. Similarly, if you have many more two non-touching loops, you have to multiply them and plus and so on. That is sum of gain product of any two non-touching loops. And if you have any three non-touching loops, L1, L2, L3, so on. Okay, so that is how it goes on. And right, now what we must do is we must know what is this delta I. Right, delta I is nothing but delta for the part of the graph which is not touching the kth forward path. Okay, this you can see when we are looking into problems. Okay, till now I hope some basic things about signal flow graph are clear for you, right?